Hello everyone, welcome to your second example on solving an electric circuit with two potential sources. So we need to find the current flowing through each of these resistors. We have two potential sources, 10 volts and 5 volts. We've got these three different valued resistors. Now the first thing you want to do is pick one of these voltage sources and assume that your current is starting from there. If it turns out that it doesn't actually start where you thought it did, your answer will just come out negative, which is completely fine. So I'm going to assume that we're starting off right here with the 10 volts. Here's my plus side, here's my minus, there's plus, there's minus. If I start from the 10 volts, so my current is going to come out of here, so we'll call that I0. I0 is going to go through the 10 ohm resistor, get to the first junction, split, so I1 will continue on through the 5 ohm resistor and the 5 volt battery. And it will come to this junction where it will meet the other portion of the current that split, which was I2. So I1 and I2 merge, forming I0 once again and heading back to the battery. So making an expression for Kirchhoff's current law looks like this. I0 is equal to I1 plus I2. So that one is pretty simple. The sum of the currents going into a junction is equal to the sum of the currents exiting the junction. And now for Kirchhoff's voltage law. So in each of these sections, you're going to draw a loop. It can start anywhere and it can finish anywhere. So I'm just going to draw my loop like this. So there's loop A, there's loop B. They don't even have to be going in the same direction. They don't have to both be clockwise or counterclockwise or start in the same way. I just do it because it's easier for me to keep track of it like that. All right, Kirchhoff's voltage loop A. Kirchhoff's voltage law A. I guess it could also stand for loop. All right, so starting from the top, I can see that my current I0 is traveling through the 10 ohm resistor. That means there's going to be a voltage drop here. And according to Ohm's law, V is equal to IR, I can represent voltages as simply the product of current and resistance when I don't have the actual voltage value. So this will be a voltage drop. So that's going to be minus I0 times 10 ohms. Right, so we follow this loop, and now we hit the 2 ohm resistor. And guess what? We're moving in the same direction as I2. Hence, that's going to be a voltage drop. So minus I2 times 2 ohms. Keep following the loop, keep following it, right? And we get to the battery where we have to travel from minus to plus based on the direction of our loop. So if we go from minus to plus, that's a voltage lift, right? So that means we're going to have plus 10 volts here equals to 0. Now I'm going to just clean this up a little bit, so it's going to look like this. Minus 10 I0 minus 2 I2 plus 10 equals to 0. Now I'm going to go ahead and divide both sides by 2. Okay, so if I divide 0 by 2 on the right, I get 0, so that doesn't change. But if I divide the left side by 2, I have to divide each piece by 2. So that means I'm going to be left with negative 5 I0 minus I2 plus 5. Okay, so that equation will come in handy later. Okay, so there's that. Let's do Kirchhoff's voltage law, B. So starting from here, I1 is going through the 5 ohm resistor, so that's a voltage drop. So we have minus I1 times 5 ohms. And then I1 also goes through this battery, but it's going from high voltage to low voltage, so that's a voltage drop. So minus 5 volts. So keep following this loop, keep following it, and we hit the 2 ohm resistor again, except this time we are going up while the current goes down. Therefore, that's going to be a voltage gain. So it'll be plus I2 times 2 ohms equals 0. So let's clean that up just like the other one. So that's going to be minus 5 I1 minus 5 plus 2 I2 equals to 0. All right, now something that should immediately strike you as different between this problem and the one done at the end of the lesson video is that that one had 2 equations and 2 unknowns. And while I still arrived at 2 equations, I have I0, I2, and I1 as my unknowns. I have 3, which means I have to use a third equation to help me simplify things. And that's where Kirchhoff's current law comes into hand. I'm going to replace I0 over here with I1 plus I2. Okay, so that's going to get substituted in. So I have then negative 5 I1 plus I2 minus I2 plus 5 equals to 0. So minus 5 I1 minus 5 I2 minus I2 plus 5 equals to 0. So let's collect our like terms. Negative 5 I2 minus I2, that's going to be negative 6 I2. I still have negative 5 I1, and I have plus 5 and equals 0. Okay, what I noticed right away is that I've got negative 5 I1, negative 5 I1. So if I isolate for both of those, I can set those two expressions equal to each other. So why don't we do that? So negative 5 I1 is equal to 5 minus, oh no, hang on, let me get the signs correct here. If I keep this on the left side and I bring everything to the right side, everything that gets moved switches its sign. So that means it's going to be 6I2 minus 5. Okay, so we'll call that equation 1. And over here, isolating for negative 5I1, we're going to get positive 5 minus 2I2. So that'll be equation 2. Now we're going to set equation 1 equal to equation 2. All right, so negative 5 I1 equals negative 5 I1. So on the left I have 6 I2 minus 5, and on the right I have 5 minus 2 I2. And so collect your like terms. So I'm going to have 8 I2 on the left, and I'm going to have 10 on the right. So I2 is 10 over 8. So 10 divided by 8 is 1.25. So I2 is 1.25 amps. So there's part of it done. So that's the current through the 2 ohm resistor. That's how we'll have to express it in our final answer. Now we have that. We can choose either of these formulas to find I1. I'm going to use equation number 2, but it doesn't really matter. So negative 5 I1 is equal to 5 minus 2 times I2. So that's 1.25. 2 times 1.25, that's 2.5. So 5 minus 2.5 is 2.5. And that's equal to negative 5 I1. 2.5 is the same thing as 5 over 2. So that's equal to negative 5 I1. I can cancel out a 5 from both sides, leaving me with I1 is equal to negative 1 over 2, or negative 0.5 amps. So why did the answer come out negative? Well, that just means we chose the wrong direction for I1. That means the true direction for current I1 is going to the left through the 5 ohm resistor, which is fine. We still have the correct magnitude. And that's really what counts at the end of the day. But like I said in the other example that you saw at the end of the lesson video, when you're trying to calculate I0, whatever sign you get, whether negative or positive, you have to keep that when calculating this sum, I0 equals I1 plus I2, because after all, current is a vector quantity. So I1 is negative 0.5 amps, I2 is 1.25 amps. Only keep the negative signs for this calculation. So 1.25 minus 0.5, that's 0.75 amperes. So in our final answer, we're going to drop this negative, and of course these are already positive. So we're going to say therefore okay, so let's think about how we're going to say this. Therefore the current going through, so the 10 ohm resistor was I0, the 5 ohm resistor was I1, and the 2 ohm resistor was I2. So let's just figure out how to write this. The current going through the 10 ohm, 5 ohm, and 2 ohm resistors were, okay, so we're going in order, I0, I1, and then I2. 0.75 amps, 0.5 amps, notice I dropped the negative sign, and 1.25 amps respectively. Respectively just means whatever order I set up here, it's the same order down here. So 10 pertains to the first number, the second term pertains to the second, the third pertains to the third, etc. Okay, and there is our solution. So I hope that was okay. That is the end of this Additional example on two potential sources.